Assalamu alaikum. Today we are going to understand Newton's laws of motion. So there are three laws of motion in Newtonian mechanics. We will look at each of the laws one by one. So the first law of so basically Newton's laws are important in understanding forces and their effects on moving objects and objects at rest. We know that a force can deform an object, a force can change the direction of an object. We know that a force it can deform an object, it can change the direction of object. But how does it does that? We can understand these two Newton laws, and this is a very important discovery in physics. So Newton's first law states that an object at rest stays at rest, an object in motion stays in motion unless acted upon by an external resultant force. Now a state of rest means that the velocity is zero. In motion the velocity is greater than zero. So this law basically states that an object can have two natural states. Natural state is the state that the object will be in, would want to be in, and to change that state we have to apply an external force to change it. So before Newton and Galileo, scientists used to believe that an object has only one natural state, which is a state of rest, meaning that if an object is moving, it will eventually have to come to rest. They did not believe that an object also has a like a moving object can also have its natural state. For example, Earth has a natural state, it moves around the sun, it does not stop. So Earth has a natural state of moving. Now it states that, for example, to understand this better, imagine we have a football on a ground. Its natural state that it is at rest. Now it has a velocity of zero. If you apply a force, external resultant force, now not any force, a resultant force. Now what is a resultant force? First of all, resultant force is the sum of forces that act on an object. For example, you have a car which is moving with a forward force of 300 Newton. Friction force is 250 Newton. So the resultant force is 50 Newton. So due to this resultant force, the object accelerates, and this is defined in Newton's second law. We will look above further. Now an object which is in its natural state has a resultant force of 0 Newton, right? If that now the ball has a resultant force of 0 Newton, and if a body is moving with a constant velocity, now if it's moving with a constant velocity, its natural state is that it has a velocity, it is moving with a uniform velocity. So its forward force, for example, let's say is 300 Newton, and to balance and to make the resultant force 0 Newton, the friction force also has to be 300 Newton, but in the opposite direction. 300 minus 300. So an object at rest and an object in motion stays in motion unless acted upon by an external resultant force. Now if you want to accelerate this car, then you have to apply a more forward force. You have to apply greater engine force so that the resultant force is greater. Okay, now inertia, Newton's first law is also known as the law of inertia. Inertia is virtue of a body's mass. For example, inertia is a tendency of an object to resist any change in its state of motion. For example, uh, only an external resultant force can change the natural state of any object, not uh, any other force. For example, we apply a 3 Newton force in the case of this car. Why didn't it had a resultant force greater than 0? This was because the friction force was also 300. If you apply a force greater than 300 Newton in the forward direction, this object will accelerate. So inertia is the property of an object, uh, but it's a virtue, it's a measure of mass. It is the measure of mass of a body. And the greater the inertia, the greater the force you have to apply in order to change the natural state. Now, Newton's second law is basically describes to what effect can the force have, the resultant force have. Now, in F equals to ma. First of all, Newton's second law states that the acceleration is directly proportional to resultant force. Provided mass is constant. Now, m, the mass is the inertia in this case. For example, you have a table which has high mass. So in order to move it, you would have to apply a greater force. For example, it is easier to drive a car than it is to drive a truck, because a car has a low mass, so it has low inertia, meaning it won't resist that much in order to change its natural state than a truck would do, because truck has more mass, so it has more inertia, so you have to apply more force. Okay, imagine two scenarios. This is car A and this is car B. Car A has a mass of 100 kg, but car B has a mass of 50 kg. Car A has a velocity of 10 meter per second, car B has a velocity of 20 meter per second. Now, through this we can derive why acceleration is inversely proportional to inertia or mass. So F equals to ma. So in this case, the force is the resultant force. Sorry, I did something wrong here. Imagine that we are actually investigating the relationship between force, mass, and acceleration. This is car A, this is car B. Now car A has a mass of 100 kilogram, car B has a mass of 20 kilogram, and let's imagine that the resultant force acting on car A is 30 Newton, and the resultant force acting in the case of car B is also 30 Newton. So what is the acceleration produced? What is the acceleration? We will see that the acceleration would be larger in the case of car B because its mass is less. The same resultant force will cause a greater acceleration. F equals to ma. The force is 30 Newton, mass is 100 kilogram, into acceleration 30 Newton divided by 100 kilogram equals to a. This resultant force causes this much acceleration, but in this case the mass is less, so the acceleration should be much larger. F is 30 Newton, same, mass is now 20 kg into a. 30 Newton divided by 20 kg will give you a 1.5. So we saw that acceleration is inversely proportional to mass and also mass. We will also see the effect of acceleration on the force of an object, on the resultant force. This is car A, this is car B. Okay, now imagine now both cars have the same mass. Here the resultant force is 20 Newton, here the resultant force is 50 Newtons. So you will see the effect of resultant force on acceleration. F equals to ma. F is 20 Newton, m is 100 kg into a. So it would be 0.2 meter per second square over here, the acceleration. But over here 50 divided by 100 would be your acceleration. So it will be 1/2 meter per second square. So acceleration is directly proportional to resultant force.